Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 81. The topic is OAuth status list and attestation-based client authentication. Those are actually two different OAuth drafts right now that we're going to discuss. Our guests today are Paul Bastian, co-chair of the Diff Wallet Security Working Group from Berlin, and Christian Bormann, architect of digital identity and cryptography at Sprind from Stuttgart. Welcome, guys.
Hello.
Hello. Hi.
And before we dive into the topic, and I think it's going to be hard to cover two drafts in like one episode, so this is going to be a sprint. But before we dive into that, even it would be great if you guys could talk a little bit about your background. Christian, how did you get here, find yourself to be a digital identity guru?
So my background is actually distributed systems. So I have a master's degree in distributed systems. So I always had a bit of like touching points. So I work quite a bit on protocols, quite a bit on like infrastructure protocols, TCP and so on. And I was always fascinated by the security and identity aspects. And like 6 years roughly ago, it brought me back to identity. And since then, I've been involved in the space and in the past few years also then more involved in standardization. I guess the most concrete example would be a publicly funded project that Paul and I were both part of in Germany called ID Union.
And okay, well, Paul, how'd you get here?
Yeah, so I studied IT science, and then in my bachelor thesis, I got to work at Bundesdruckerei, which is the national printers company, and I did a lot of work on the physical national EID card that has some online authentication. And then I stayed at this company. I did a lot with smart cards, cryptography, and then I ended up in this SSI space in the end. And yeah, since then, so I've kind of always been digital identity guru from the start.
Awesome. Well, today we're going to talk about two different OAuth drafts that we love at Glue. The first one, I want to start with OAuth status list first, which I think is a little bit more straightforward and security architects will understand. And then I want to take the second one is called OAuth Attribute-Based Client Authentication, or ABC authentication. Yeah, well, so let's start with Christian. Why don't I put you in the hot seat and ask about, can you tell us a little bit about OAuth status list? What does this spec do?
Yeah, so it introduces a status or revocation mechanism to the OAuth world, or to be more specific, we are targeting all HOSE or COSE tokens or like credential formats out there. And yeah, a few years ago, we sat down and thought about what is missing for the solutions we are trying to build. And revocation is always this topic that comes up, and no one really likes revocation, right? Like it always feels like there is no good solution to revocation, but you kind of have to deal with it. And yeah, so we started work on the.
And can I sort of put a pin in it at that point? And revocation is so important because when the business people say, okay, the hacker is doing stuff, make him stop. Unless you can revoke, you can't actually make him stop, right?
Yeah, there's a lot of good business reasons that we need to support revocation, but revocation has been this field where technically we've never found like a really nice solution. Like every revocation solution seems to have like its pros and cons. There's not this one variant where you would say this is the perfect one you can use everywhere, right? And that is kind of the field I would say revocation is in right now.
Yeah, I think you can really well see this from the revocation that we have in the TLS space. So there have been lots of mechanisms. People started out with CRLs, and then they had OCSP, and then OCSP stapling, and now Mozilla is doing this CR Lite, very complicated stuff, stuffing everything into one.
I just want to break their pause, Paul, for a second, because you mentioned OCSP, and I think it's just worth, this is so obscure, I actually think it's worth actually like maybe just breaking down a little bit. So with TLS certificate revocation, basically you could get all of the revoked certificate identifiers, I guess, but that becomes a bottleneck if you're all getting it. So the idea is, like DNS, we're going to distribute this certificate revocation list around. And there's an old protocol that doesn't use HTTPS called, it's an HTTP protocol, meaning the messages must be signed, that actually is used to distribute certificate revocation lists so they can be locally resolved. So if you're logging in, plugging your smart card into a Microsoft computer, you can locally validate that this certificate hasn't been revoked based on the last copy of the certificate revocation list that was obtained by the OCSP local server. Anyway, I just wanted to shed a little more light on this. So what happened? You're saying after that, so it became clear that OCSP and certificate revocation, what happened after that they said, why didn't that work?
I think for both approaches, there have been some scalability issues. In OCSP, it's also like a privacy issue, because for OCSP, you explicitly say, can you give me the revocation status for this particular ID? So then the issuer of this certificate knows which one you're interested in. And you don't have this problem with, for example, the CRL, because you always give all the revoked ones. So the issuer doesn't actually know which status you're interested in. So,
okay.
But mostly, I think the most problems have been with scalability, and this is also kind of the approach that we took from status list, that we optimize for scalability.
I see. And so, Christian, maybe you could describe the difference between the statusless solution and, let's say, the X509 revocation solution. How are they different?
So the normal CRL is basically a list of objects, and the objects then contain information about the certificate, the most important one being the unique identifier. But it can also hold all kinds of different status information, like timestamp, revocation, explanation, like was it a leak key or whatever. And what we were thinking about is a lot of, or all of this meta information does not really matter for 99% of use cases for credentials. The main thing you're interested in is this credential valid or not, or is the token valid or not? And that is kind of what we chose to go with as our target. Make a very easy solution, easy to implement and scalable, and concentrate really on the core features we need for that specific space. Do not try to solve everything, only this problem.
So I understand the design goal then was to make this more scalable, because copying around lists of IDs, even the ID itself, would have been multiple bytes long, right? So even if you have just the identifier for the certificate, that itself is a bunch of bytes. So the idea was, by making it more scalable, we're talking about making sure that we're sending around a much smaller chunk of data that contains all of the updates. Paul, maybe you could go into more of the details about, that sounds like magic to me. How could you send one piece of data that's 256 bytes, or and give the status of every token you've issued?
Yeah. So the idea of the status list is that we represent the status of one certificate, or in our draft we call it a reference token, with only one bit in the simplest version of the status list. And in contrast to the CRL, we not only put in the revoked ones in the list, but we put every certificate that we issue into the list. And then in the certificate, we point to this status list, and then you also have an index. So with this index, there's a very long byte array that represents all the issued certificates. And then
when you say very long, how is very long? Are we talking about a big company might run out of them, maybe, if they issue a lot?
Yeah. At some point, you can also chunk them into multiple lists if they get too long for your use case. But the interesting part is that there is one bit for each issued certificate, and naively you would assume, well, this would scale worse than the CRL because the CRL only includes the revoked ones. If you take an average revocation rate of 1%, then you would say, okay, in the status list, I represent 100 certificates with 100 bits because I need 1 bit for all issued credentials. In the CRL, if I have a revocation rate of 1% for 100 credentials, there's only 1 entry, but this 1 entry has a very long serial number, the unique identifier for the certificate. And the magic here kind of happens that because there are so many zeros in this byte array in the status list, they actually compress very well. So you're not actually talking about 100 bits after they are being compressed, but like a very, very tiny amount. And so in general, if you talk about similar configurations, the status list would probably scale about 4 to 8 times better than a CRL. So you can incorporate more certificates, more reference tokens than a CRL in the same size.
Right. And so, Christian, this idea would have some impact on how developers need to validate JWTs, right? Because now we're saying just validating the signature is not enough. There's this extra step. Or can you talk a little bit about what's the impact on the use of JWTs?
Yeah, so in JWTs right now we have validation algorithms already defined, right? And one of the first step is checking digital signature, of course. But then we also are checking for things like expiration, or in general correctness of the payload. And this is then basically an additional check where you have status information in your JOT. The status information references a bit in the status list. You, as a relying party, would then get the status list, check that bit, and check the status of that bit. So if the status is then valid, the overall status of the JOT is valid, and if the status list bit is invalid, then the JOT becomes invalid.
Right. And so when you say check the status bit and you get the latest status list JWT, what you've done is basically suggest that there should be on, let's say, the configuration endpoint of the authorization server, there should be a URL that says, here's where you get the latest status list. So if I'm a client, I can download the latest status list and then validate the index of the JWT against that status list that I downloaded from the trusted authorization server. Is that right?
There are different mechanisms, like the status claim inside the JOT. Let's say it's an access token, that would also have the URL where to get the list from. It would have the index that you need to look up, and it would have the URL.
Oh, okay.
But you can also, of course, use metadata or other mechanisms.
It might actually be quite interesting that there is some place in the metadata that defines a place where to get those status lists as a second mechanism, because that would enable you to prefetch all status lists that you may need for a particular use case. If you think about that, you have a massive use case where you have very, very many. Then you may want to chunk your status lists into multiple buckets, and then it actually makes sense that you also have a place to fetch all of those status lists at once.
Paul, I have a very existential question for you about this. There's a lot of work going on around SSF server. I guess this is events that are set. There's CAPE, another OpenID effort to share events between different parties. Do you think that this mechanism of revoking tokens could actually solve some of those asynchronous challenges that we see CAPE or the other security SEC events solving?
I don't actually know SSF too well, so I think I need to pass on that question. Okay.
Yeah, I was putting you on the spot. I don't know. It's interesting because, I'll just speculate. I'll take it myself, I guess. Let's take session logout as the poster child for this. federated identities never be able to come up with a good way to log out either. And maybe these are similar problems in a way. And so, I guess if you want the person's like terminal to instantly close, maybe this doesn't work. Although I think we get into a conversation of whether what is better, to push events or to have the client poll. And if the client is polling the status list and it can keep checking its JWT, you could potentially affect a logout using this mechanism in a similar way that you could do as if you had pushed a message too. That was my thought.
Yeah, my thoughts on this are maybe that I think in a lot of OAuth use cases where you have scalability issues, people tend to have rather short-lived access tokens instead of using status mechanisms and revocation, because revocation is really complicated at scale. And I think many people have used introspection endpoints for access tokens, which are actually, I would say, more similar to OCSP. The downside of this is that when you hit the introspect endpoint, then you actually need to look up this access token in your database. So it's kind of a dynamic request. If I would use status list, it's actually just static data. And I can serve static data quite well because the data itself is signed. So I could even put that on Amazon hyperscaler, and then I could serve a huge number of revocation requests, because static information is more easily servable than dynamic requests, in my opinion.
That's fascinating observation. Christian, before we switch, I want to switch to attestation, to the ABC authentication. Any last thoughts on this status list before we pivot?
Would be nice to get a bit more implementers feedback. I think we are pretty far on the spec. It's currently in working group last call, so we are hoping that we go final real soon. I would say most of the bigger challenges are dealt with. It would be really nice to get a bit more like feedback from the community, people implementing this, using this, and so on. Because part of the problem for status list was that we were trying to create a somewhat generic spec, which has like a lot of broad possible uses, and that makes it also a bit difficult, right? Because you have different use cases that require different things, and we've tried to somewhere find the correct spectrum there, but it would be really nice to hear a bit more feedback.
Okay, well, you're in the right place for that. That's what we're all about here at the live stream, is helping the people get the word out. So Paul, let's ABC authentication. We named it on this live stream. So I made a sort of joke on the live stream on non-human identity about attestation, like being the geeky jargon word of the year for 2024. I feel it's like assertion was probably in 2001. Like, and so this idea that a client during client registration, let's say, is going to say, here are the facts about me. I'm this type of client, and here's what I like to be called. Here's my URL. What we might call the entity ID. What's my entity ID? It's self-asserted, or the client might also assert even a software statement. But can you tell us what is this? Why is it called attestation-based client authentication? And sort of can you give us a little of the background of the history about how it came about?
Yeah. So the motivation for this client authentication is that when we looked into this verifiable credentials ecosystem space, I looked at this from like a high security perspective, because we're working for the Federal Printer's Office. So we're issuing national ID cards, which have like a very high security standard. And we're in a regulated industry. So whatever we actually want to roll out in production needs to fulfill certain regulatory requirements. And for a lot of things, these are quite high. And a lot of people looked at like issuers and verifiers and the trust infrastructure, but it looked to us like nobody's actually looking for the wallet. And if I have for example, an identity credential that's proving I'm really Paul, then I need to be sure that nobody can extract this credential from the wallet. So we have some requirements on the wallet side and how to really make sure this credential is landing in the correct wallet, and ideally also it cannot be extracted. So that was the motivation, and we started this in the diff group, wallet security that you mentioned in the beginning. I'm actually not leading this group anymore because after 2021, 2022, we've seen like a shift in our industry, especially in Europe, away more from the DITCOM side, more to the OpenID for VC ecosystem, and therefore it made then sense. And this is how we ended up in IETF, because OpenID for VC is based on OAuth. So we said like, okay, if we have a client authentication scheme that could also be used for other mechanisms. And then this generated a lot of interest. And this is potentially why then attestation became such a buzzword in the beginning of 2024, because then we came to the OAuth group and suggested this as a draft, and it was very welcomed. It took us quite a time and to progress this, because there were some bigger questions behind this. And yeah, we kind of now ended up a little bit different than what our thoughts in maybe 2022 have been. Yeah.
Let me pivot to Christian. My original thought, my original reason I like this spec was because I felt like there was no stable identifier for the client. And I remember Tobias Looker and Christina Yasuda at IAW were talking about how, in SAML we have an entity ID for both the IDP and the SP, but in OpenID we have a stable identifier for the OP, the configuration endpoint, but we don't. But the client gets a client ID, which is contextual, and so that makes it hard from a policy standpoint, I think. So was that actually addressed? And if that was addressed, what's the delta of what also attestation-based client authentication does over just giving a stable identifier?
So that's a long question.
Sorry about that. So, you want me to repeat it?
No. I think it's fine. I think there are several aspects. Like initially, when also the diff working group was happening, there were different thoughts exactly what an attestation would contain. And initially, I would say the attestation was like a very big thing, which was like all of the necessary information about a client. Like it was this giant one attestation, and that is all you needed. And it was like everything in one, like basically operating system, software, key attestation, all of these in one. And then perhaps, depending on case, also providing a stable identifier. In that whole space, we've seen though that like we need trust in the RP and we need trust in clients, right? And oftentimes the client are the devices that are user bound. So there you do not want a stable identifier for the specific client. You might want one for the, let's say, type of client. And the same thing happened in WebAuthn, right? In FIDO, you currently also have the authenticator info. So you have some form of attestation about the authenticator. But it's not like an identifier in itself for that specific client. It is one about the class of client, I would say. And that is...
Yeah, I was going to bring up, I was actually concerned about bringing it up because I never know what the overlap is between people who contribute to OAuth and FIDO, or passkey, maybe we should call it. But correct, the authenticator has an attestation. This is the other place we hear this word a lot. And then it's really important in FIDO because that authenticator could have a device-bound private key, like a YubiKey, or it could be a shared key, like an iCloud keychain key or a 1Password key, passkey. And so the device, I guess, asserts that I'm this type of device, because that's important for the IDP to understand whether that key is actually unique or whether it's replicated on different devices. So, but relating this to the RP, so it sounds like you're saying that that initially they wanted to include everything in the kitchen sink inside of the attestation, and made the assert. So it included an asserted identifier plus all this other stuff. What's the right amount of information actually? Where did you come out in the spec is the right amount of information for it to be required or optional? Maybe Paul, you want to take that? Yeah.
Yeah. So especially if we talked about like what's the key that's asserting that, because that was something also very important for the regulatory requirements, because in the end, then in the verifiable credentials ecosystem, we want a strong key for the credential that we bind to a key later on. And so we had like two purposes in there, and in a lot of IETF discussions, then we ended up that we say, okay, the attestation-based client authentication is more about the client authentication, that we say, this is really this client that you're talking about. So it's more like in the verifiable credentials ecosystem, you are talking to the government German wallet. And the part that we need secure keys, that we really know, oh, this is really a hardware key, is kind of a second topic. And we extracted the second topic of these key attestations into the OpenID for VCI spec. And I think that was an important step forward to move this forward. And we also think, Christian and I, that it could make sense to actually extract this key attestation into like its own separate spec out from OpenID for VCI, so that could also be used in other contexts as well. And you could also say, oh, I really want to even secure my client authentication with hardware keys if I have really high requirements. But the core of attestation-based client authentication is more of, I am exactly this client and I can prove it. And I think what makes the differentiation then to other client authentication schemes is that we have a new class of clients that is somewhere between public clients and confidential clients. And I think this is where attestation-based client authentication is trying to fit in, because we have wallets. The wallets that we will use on the verifiable credentials ecosystems are mostly native apps. And I cannot put like confidential information like client ID, client secret. I cannot put this in the app easily, because it's quite easy to extract this information from an app that's installed.
Yeah, in fact, most apps use PKCE, which I would argue is not client authentication. It's like a server state.
Yeah.
But I think it's not well understood that most mobile clients, Android or iOS, don't authenticate at all. They're unauthenticated, and that they that means that you don't actually have a cryptographic binding to that particular device. And the wallet itself is just a piece of software. As you said, it's a piece of software running on an iOS or Android phone. And what you're saying is it's going to make an attestation. So I'm the German government wallet software, and I have to do a good job protecting my keys. So you can. So what exactly? I guess it's saying here's my public key, so you can send me a challenge to authenticate me. Is there? Let's say I have a wallet on two devices. Maybe you can explain it like that. Are those actually different? Do I have different attestations for both of those devices?
I would think so. I think the fundamental difference to other client authentication schemes in OAuth is also that they would usually do this through the back end. So if you think of a wallet probably has a native app as a front end, but also like a backend server for some certain things. And then at Torsten, when I discussed these things with Torsten said, of course, then the client authentication happens through the backend. But for privacy reasons, we actually didn't want to do this. So the idea behind it, maybe you can think it like this, is that the wallet backend is asserting the wallet front end with an attestation, and then the front end can go to an authorization server and say, hey, I'm really this because it's being attested by my wallet backend, and I can show you to this because it's bound to a key that I possess. Maybe that explanation helps to some of the folks that do traditional OAuth.
I think Paul just answered this question, Christian, but I'm going to ask it to you also because I think it's sort of conceptual, and people have a lot of hard time with the word client. Like I always say the software instead of the client because it gets very confusing. Client means different things across protocols. But so Christian, I guess my question to you is like, so it sounds like what we're saying is that the software running on the phone could register itself using dynamic client registration in OAuth, but you didn't think that this was a good fit or didn't scale as well. And maybe you can dig into, I think Paul just answered this very question, but maybe I just need to ask it again. Am I correct about that? And why is ABC authentication better?
I like the new name. Although we are competing with attribute-based certificates or credentials.
AVAC?
ABC, attribute-based credentials, yeah.
Oh.
Yeah. So in a traditional way, I see an OAuth client is a static registration to a certain degree, right? Like classically an OAuth application, and like all people who have worked in like big enterprises know that you somewhere register an OAuth client and you get a client ID, client secret, and that is a somewhat static thing. Then dynamic client registration came about, but it's still this, you are now registered to this entity, right? Whereas in the systems we are seeing right now, it's becoming more and more dynamic. There might be only one interaction you have with a certain party. And for these kind of things, it made, in my opinion, more sense to talk about verifiable properties of the system you are interacting with. Like, I want to make sure I'm really interacting, let's say, with the wallet inside a certain trust ecosystem, and that is enough to create certain trust in that client. I do not know, or I do not have to know exactly who the client is, etc. But there are some like general assertions I need to make about the client, and that is, I think, this where we are between the public and confidential client concept somewhere in the OAuth world.
I don't know why you're not a confidential client. Why wouldn't you just say this is a way to achieve confidentiality without having a shared secret?
Could also be. I guess that also depends on the use case and ecosystem, like what kind of requirements you have towards confidential clients. But yeah, it could also be a different kind of confidential client, I guess.
You know, it reminds me a little of software statements because in dynamic client registration, anyone can hit the DCR endpoint and get back a client ID and secret. But if you present a software statement, then the AS can verify the integrity, the signature of that software statement, and then perhaps give your client more privileges in return when it returns your client credentials. So in a way, I think what you're just saying is that the attestation, which can be trusted by the AS, I guess, the authorization server sees this. You're still registering, or you're not. You're skipping the registration part altogether. Is that what you're saying, Paul? Maybe you could take this one. You're not even doing client registration.
No, not really. And maybe that's also like caused by the different thinking model in the wallet ecosystem. Because with the client authentication, I just want to say, like, I'm wallet XYZ, the relying party, so and this client authentication would then be for everyone who has this wallet app installed. So that's kind of the same thing, and therefore it's fine that these all ones have kind of the same client authentication ID, because then the relying party could say, oh yeah, I'm trusting this kind of wallet, because from like a software perspective, they're all the same. And like real identification would then happen later on with a verifiable credential, but the relying party or issuers would only be interested that, yeah, this is a particular software of this wallet.
Okay, it's starting to make sense now why it's attestation-based client authentication and not attestation-based client registration. By the way, I think there's also one of those at OAuth. Now that you mention it, and so this transaction model is optimized where you're not doing a lot of, let's say, transactions with this particular piece of software. This is optimized for low number of interactions with this particular piece of software.
Yeah, and it's also optimized for privacy. I saw a comment here, but there's some overlap to the REDS framework, and we've also put that into the spec. The REDS framework is I think remote attestations as well in its own like IETF group, and they differentiate between the passport model and the background security check model. So I think we fit into the passport model, and then we do that for privacy reasons, because we don't want the backend to know to whom I'm connecting, and we want to keep this information in the front end.
Okay, well, you know what? We're only at 36. I was going to go to last thoughts, but you know what? I'm going to ask one more follow-up question. Christian, you mentioned before about getting adoption and feedback from implementers, etc. Has there been any feedback on ABC authentication? Any early implementations?
We've definitely gotten some feedback now that the authentication-based client attestation-based client authentication is used in the OpenID for VC world. But for a long time in that draft, I would say that there was still this overarching discussion happening, basically how to chunk it, like what kind of attestations do we have? And like only a few months ago that got really clarified, that we have to have these key attestations and we have to have the client attestations or wallet attestations, etc. And I would say there was a decent amount of feedback, but it's still an ongoing discussion, and that spec will definitely take a few more months until it's fully finished. So yeah.
I think that the spec needed a lot of clearance about exactly what's the relation to dynamic client registration and what's the difference. And we had like extensive discussions on this on the OAuth security workshop last year in Rome. But in the end, yeah, we convinced all the folks that this actually makes sense. But it seems that it's hard to grab. And maybe as a final other mental model to this, the native apps have some app attestations. They have some features to authenticate towards like their own backend. And attestation-based client authentication is kind of a mechanism that could use these features but enable them to any third party so that you can authenticate native apps. It's not limited to native apps, but our motivation where we're coming from is the native apps, but you could use it for anything else as well, of course.
You're talking about Google has an integrity API where you can call it and get an attestation about the device. I believe you can also get an attestation about whether the software has been modified. So does the checksum that's installed on the app match the checksum that's in the Play Store or the App Store? And has this device been rooted, in which case all bets are off?
Exactly. And that's what we're doing in the German wallet project. Exactly this. We're using these mechanisms to see the wallet app is not manipulated, and then we can put this information into an attestation and then give it to authorization service.
Mhm.
So they are sure they're really talking to a non-manipulated German wallet.
Right. But the wallet is not, so you're saying that just like you could present that during dynamic client registration, you could also present that during this authentication, this shortened one-off authentication process.
Yeah, and we also put it that way that you can actually, I think, use it for dynamic client registration. So we put in a version to use it with HTTP headers. So you can also integrate that into other protocols and not only directly to the authorization server.
Okay, we could keep going. Let's do last thoughts. Christian, last thoughts on either spec?
It's going to be an interesting year. We plan to finish both rather soon. And in general, in the space, I think this year is going to be super interesting because like this is the year where stuff needs to get finished for a lot of specs and protocols.
Paul?
Yeah, it's a very interesting journey. ITF is a great place to write standards. You get a lot of tough but honest and good feedback, and it's really fun to write these specs. And I hope that they are well received and we can make things happen with this.
Awesome. Okay. Well, I just want to remind everyone, follow Identity Office Hours on LinkedIn. Next Tuesday, we have Achieving Standard DID Methods with Daniel Buckner. Very excited about that. And thank you, guests. Thank you, audience. And we'll see you next time.
Thanks for having us.